Quantum mechanics, the realm of subatomic particles and bizarre behaviors. It might sound like an abstract distant science, but it's right here in your kitchen. Your toaster, glowing with that familiar red heat, is not just making breakfast. The red glow of your toaster's heating element is a classic example of blackbody radiation, a phenomenon that baffled scientists in the 19th century. Physicists couldn't explain why heated objects glowed certain colors. Then, in 1900, Max Planck proposed something revolutionary. Energy is emitted in discrete packets called quanta. This breakthrough marked the birth of quantum theory. As electricity flows through your toaster's metal filaments, resistance heats them up. Electrons within the atoms jump between energy levels, releasing photons of specific frequencies, giving you that red glow. This everyday light show is driven by Planck's constant, a fundamental pillar of quantum mechanics. Your kitchen's fluorescent bulb is another quantum marvel. When electricity excites mercury atoms inside the tube, they leap to higher energy states. As they return to their ground state, they emit ultraviolet photons, invisible to us but very real. These UV photons collide with the tube's phosphor coating, which absorbs and re-emits the energy as visible light. This two-step quantum process is why fluorescent bulbs are far more efficient than old incandescent ones. But quantum physics isn't just about light. It powers the brains of your devices. Transistors, the building blocks of modern electronics, are so small that electrons sometimes pass through barriers they shouldn't be able to cross, a phenomenon called quantum tunneling. As transistors shrink to the atomic scale, quantum tunneling becomes more pronounced. While this can cause leakage, scientists are using it to create faster, more energy-efficient components. Single-molecule transistors, tunnel diodes, and even quantum computers owe their existence to this effect. The quantum world reaches far beyond your toaster. GPS systems rely on atomic clocks, using quantum mechanics to keep precise time. LED lights use quantum effects for their bright efficiency. Even MRI machines in hospitals exploit quantum properties to visualize the human body in incredible detail. Quantum mechanics is not confined to laboratories, it is embedded in your morning routine, your gadgets, and life-saving medical devices. The invisible quantum dance underpins much of our modern world. So the next time you make toast, remember, you're not just making breakfast, you're witnessing the quantum fabric of reality.